Hello, this is Porter Nielsen with Random Artech, and today we're going to be going over part 4 of the minigame tutorial series in Unity. The topics we're going to be talking about today are shooting the arrow, how to actually add, so we have a script where we can pull it back and release the arrow, but we're going to add a relative force, variable manipulation of other scripts, and enabling and disabling scripts based on what's going on. So it's going to shoot the arrow forward. What you'll notice as we shoot the forward over, or out, it won't rotate. It'll just basically shoot out straight. And so we want to arc the arrow using trigonometry. So we're going to be talking about finding the angle of elevation with trig, rotations of objects based on velocity, and there is about a 5-minute math lesson, which is all good video game math geometry. So the last thing is embedding the object on collision. So as the arrow hits, we're going to be using OnTriggerEnter and manipulating the arrow body so it actually stops, and that's about it. So let's go ahead and get started. So let's go ahead and create the projectile arrow force. So create a new script, C#, and again, projectile arrow or projectile add force. Go ahead, go to MonoDevelop or Visual Studios or whatever else you would like to use. I'm going to go to the projectile add force here. So dealing with the rigid body, go ahead and create rigid body, variable name rigid b. I like to keep it the same. Create a public function, float shoot force, because I want to be able to affect this from other scripts. You can change it to whatever you want. I'm going to start with 2000, see if I like it. Instead of start, I want enabled and disabled, so whenever I enable this, it's going to be rigid body gets component rigid body. And just in case there's velocity, I'm going to say rigid body velocity equals vector3.0. So I'm basically taking away all the velocity of this rigid body. So basically two methods. There's going to be an applied force, and then a second one that's going to affect the arrow's direction that it's facing, kind of thing. So apply force. Let's go ahead and do the following. So rigid body dot add relative force, so it's going to be adding it in a certain direction. So what you need is basically a vector3, which is direct direction, so vector3.forward, times by shoot force. So it's going to be shooting forward by that amount. So the next method, let's go ahead and call this spin object in air. And what this is going to do is basically going to spin the arrow. So it rotates up or down based on the velocity. And you'll see what I mean by that later. And we're going to run it in the update spin object in air. So let's go ahead and open up our shoot class where we're going to be applying this. So I'm going to create a new variable. Oh, actually, I'm trying to think, do I just want to call it in the method? Yeah, I'm just going to put it right here at the top and say projectile add force underscore arrow projectile, and that equals get component projectile add force. Okay. And then throughout the course of this shooting the arrow, we're going to change the force of this, or enable this script, or disable the script. So where do we want this? Do we want it on mouse down? No, because that's when we're pulling it. So we want it after kinetic is false. So, right, yep. Now, we're going to be changing the shoot force based off the pull amount, so I'm going to put the pull amount to 0 later. So we're going to do arrow projectile dot shoot force equals arrow projectile, oh, sorry, underscored that, shoot force times pull amount divided by 100. So it's going to be percentage out of 100. But I want to be a little bit more than 0. So maybe plus 0.1 or 0.05f. So there's never going to be a minimum of 0. It's always going to be at least 5%, but it can get up to 105%. So that's going to change the shoot force there. And then we're going to enable the arrow projectile. So right here, I'm going to say arrow projectile dot enabled equals true. So as soon as we run this, it's going to go ahead and enable the projectile first, and then we'll apply the force upon enabling. So as soon as it's enabled, it's going to shoot once and then spin it in the air. So let's see what happens with this. Now I already caught a mistake, so let's see if that mistake carries through here. So I'm going to go to my shoot position's good. Got to go to my prefab arrow, projectile add force. Yeah. So I'm going to disable this. So when it spawns, it's actually not being applied because we don't want to apply it till we release it. So let's see what happens. And it's not working. So it's enabling the script, but it's not working quite right. So let's go ahead and look at these mistakes. First, I'm doing get transform, but it should be the arrow transforms get projectile. Otherwise, it's trying to get the component from the shoot position. We also have the enabling at the wrong position. We want to move it up to where I had it right there. So I'm going to change the force to 500, see how that works. And you can see it's working. Now you can see that these arrows aren't rotating. They're just kind of going straight, and it's not very visually appealing. We want to arc down kind of with the weight of the arrowhead. So I'm going to show you some trig, and then we're going to implement a very simple function. Okay. So what's going on, mathematically speaking, is you have this arrow, and it's going off like this. Okay. The angle right here, we're going to call theta. Now, as it follows this arc, the arrow keeps on the same, so it's basically staying parallel. So this angle of elevation here, theta, isn't changing. We want this to change. Every vector has basically two components. You have an x component and a y component. So this vector right here is velocity. And if we can calculate the y velocity and the x velocity, we can find this angle here and set our arrow to that. So that's not very hard. The problem lies in this. It's a three-dimensional shape. So our arrow's going like it's going along an x, a z, and a y, not just an xy. So my arrow's going like this. And so this is still a y velocity. That's still super easy to get. But this is no longer a y velocity. Let me show you this using Blender. So here's the path that the arrow is going to follow the vector. So this is z, this is x, or vice versa, and then up and down to y. Now there's three dimensions to this, so going straight down would be the y velocity. But this right here has a z and x component, making that right triangle. So I need the opposite side, which is y, but then I need this side, which is actually going to be the Pythagorean theorem from the x and y. So here we have... Oh, let me go ahead and fix this. There we go. So this diagonal has a z and an x component. So this base needs to be x squared plus c squared, square rooted. Okay, so let's look at this. So from a top view here, we have, so this is the new component we're trying to get. We have the x velocity and the z velocity, forming this right here. So what you need to do is you go x squared plus c squared, square rooted, and that'll give you that. So my theta here, trying to get the triangle that we're looking at, the theta that we want is going to be the y velocity, and by using the square root of x velocity squared plus the z velocity squared. And so I'm going to call this adjacent, and I'm going to call this opposite, not adjacent. Other way around, sorry. Yeah, it should be opposite that. Opposite over adjacent, not adjacent over opposite. Sorry about that. So theta equals arctangent of y over square root squared x squared plus c squared. So this is the math to find the theta we want. So whenever you want to find a theta of any triangle, it's just basically opposite over adjacent. So I did it correctly there. There we go. So let's go back to Unity and create that script there. So in my scripts, we already have this projectile add force spin. So we're going to be working with variables. So we need a y velocity float underscore y velocity equals rigidbody.velocity.y. Easy enough. So this is giving me this y velocity right here. The second thing we need is the x velocity. So float x velocity, or z velocity, excuse me, equals rigidbody velocity.z, and we're going to do the same thing for the x velocity, rigidbody.velocity.x. So let's give me the three different velocities. So we said fall angle, so float underscore fall angle equals arctangent. So math f arctangent 2. I like the arctangent 2. So it needs two things. It needs the opposite side and the adjacent side. So the opposite is easy. That's just the y velocity. And the opposite is going to be float combined velocity, and this is going to be math square root of x squared, so x velocity times x velocity, plus the y velocity, z velocity squared, excuse me. So it's just that twice. And that's going to give me that, the base, the adjacent side. There might be an easier way to do this, but this is kind of how I did this using math, and it works great. So now, the problem is, arctangent doesn't give me degrees, it gives me radians. So we need to go ahead and convert this, so let's go ahead and look at the math. So it's very easy. Converting between radians and degrees, super, super easy. Degrees, half a circle is 108 degrees. Radians is pi, so 3.14159. So you can use that as a ratio. So if you have radians, you times it by 180 divided by pi, and vice versa. Degrees, you just go times pi divided by 180, and that'll convert between the two. So since we have radians, I'm going to go 180 divided by math f dot pi. I could have just done 3.14159, and it would have been fine. Now we have the fall angle, so the angle we want to change this arrow. So transform Euler's angle equals vector 3 fall angle, so that's the x value. So let me go ahead and grab this prefab. So the x rotation is basically moving up and down like we want. We don't want the z or the y, we just want to affect the x. So I go ahead and leave these as transform dot Euler's angles dot y and transform dot Euler's angles dot x. So it's keeping the x and y the same of the original transform. Now, math arctangent 2 needs -1 out front, so I go -1 times this, otherwise it flips it. So going to go ahead and maximize this so we can see. And it's working the way that we want. It's arcing. Now we also want these arrows to embed because as it stands, it's kind of just sticking there, right? So let's create a new script. Let's call this embed behavior. I always feel a little self-conscious about how I name things, so hopefully you're not laughing too bad at my generic naming. So I'm going to say rigid body, again, rigid B. And then I also want to find the rigid body here, so rigid B equals get component rigid body, and parentheses there. So we've done that like 400 times. So we're not going to be doing update, we're going to be doing OnTriggerEnter. And it takes a collider, so I'm just going to call it col. So as a trigger gets entered, we want to start to do all the information and the logic behind this. So another method, let's call this void embed. So as I look at this, I want to go ahead and put transform dot. Okay, here we go. Transform dot get component projectile add force enabled equals false because we want to get rid of that. We don't want to be arcing based on velocity. Rigid body velocity, let's say vector equals 0. Set use gravity equals to false. So we're going to go ahead and turn off all the physics basically. technically speaking, you could just use is kinematic equals true, and you won't have to worry about this. So you could take out that use gravity. So now as the arrow hits, it's gonna take off the projectile at force. It's gonna stop the velocity, and let's see what happens there. So embed behavior, and let's shoot this out. Boop, and it's just sticking great. It's looking quite nice. If you've ever played games like Skyrim, they might use something similar to this for their physics. When you get hit by arrows, you can kind of see the arrows like go into your character and stuff like that. So we're just shooting arrows. If they're embedding too much or too little, you can actually go to the collider. You can't really see, so I'm going to hide that. I actually changed the Rigidbodies, so it's way, excuse me, not the Rigidbody, the collider, way ahead. So I'm going to go ahead and edit this, and you'll notice it's a trigger. Yours might not be a trigger. It should be trigger because we're doing on enter. So I'm going to make that a little less shallow. It takes a little bit of the physics to calculate, so that's why it's going to overhit just a little bit. And you can see it sticks in a little bit nicer. The faster it goes, the deeper it embeds because the physics has to catch up. So it's looking pretty good. I'm just having fun. Oh, there's no collider on that. That's why it's not sticking. So that's it. Your homework for tonight, or for the week, or for the next month, whatever, is to create script to move the targets. I haven't shown you how to do this, and this is probably going to be the most important homework that you do. So I want you to create a script to move the targets. So basically have the script move between predefined waypoints. So let's say you have 3 waypoints. The target would just go between those 3. And then implement that in Unity. And again, if you do this yourself and figure out a way to do it, my next video is going to be so much more valuable because you're going to see how vastly different I do it than you. And you're going to learn from the differences. You're going to see, oh, he did this intelligently here, or even he did this really, really hard this way. And it kind of gives you a deeper and a wider depth of knowledge. Thanks for watching this. As always, subscribe or give us a like. It does help us out. And check us out on Patreon if you want to help us out that way too. We always appreciate that. Have a great day.